In the previous lecture, we have seen that automated decision systems employ very accurate algorithms that in some cases are even better than humans, in particular when applied to very specific contexts. At the same time, we have seen that these algorithms can raise or worsen some issues that have an impact at the individual and collective level. An issue that is common to many different applications is related to our digital traces, that is, all data produced during our digital activities. This issue related to data does not concern only privacy, but also the consequences derived from the processing of these data, as we will see in the following part of this lecture. Transparency is a key element in decision processes. For example, schools, hospitals, and banks must obey very precise transparency criteria. Transparency is important to keep track of the elements that brought to a certain decision. Moreover, transparency is important for those who are subjected to a decision. For example, a transparent public administration should guarantee that data and processes concerning its citizens are accessible to them, so that in case citizens can contest the result of a decision. So transparency is a condition to exercise privacy and control that the processes are impartial. Transparency can be made difficult by human actions, think for example of corruption, or other factors, think for example of bureaucracy. To use machine learning tools in decisional processes can add further difficulties. The first problem concerns the fact that it is not always possible to make public all the data and information used to make some decisions. This data could be sensitive, or their disclosure could damage the involved subjects. Moreover, a second problem is connected to opacity, that is somehow intrinsic to machine learning. Even when it is possible to access the source code of the algorithm, it does not mean that the algorithm is intelligible to a human being. For example, deep neural networks produce outputs deriving from billions of arithmetic operations, where the sequence does not offer any clue of the reasons adopted to get a certain result. Automated decision systems are black boxes that hide the internal logic to the user. To overcome this crucial weakness, explainable AI provides many approaches, sometimes at the cost of sacrificing accuracy for interpretability. There is also another element worth considering, that is the intricacy of the different actors involved in the development and adoption of an automated decision system. The developer of the algorithm is, in many cases, different from its distributor and from the owner of the data. So, to attribute responsibility in the case in which the output of the algorithm is wrong can be very difficult. Another problem of machine learning algorithms used for decision is discrimination. Discrimination is often connected to the assumptions that are inserted in an algorithm. These assumptions can unintentionally lead to an unjust decision and derive from the data used to train the algorithms. For example, this data can be not representative enough. When the composition of a sample is not representative of the whole population, more Caucasian males, for instance, it is likely that the algorithm is less accurate to make predictions for those who are less represented in the sample. If the algorithm is unbalanced with respect to sensitive features, such as gender or ethnicity, this can lead to social discrimination. A study on the major commercial facial recognition systems shows how their performances decrease in the case of gender and the skin color of the classified subjects. Another problem is that an algorithm can be trained on a set of data containing biases. A bias can be statistical, when the model does not represent the data correctly, or social, when data does not represent the world correctly. Racial bias has been recognized in criminal sentencing. For example, Compass, the software already mentioned, correctly predicts recidivism in the 61% of the cases. Unfortunately, black people are almost twice as likely as white people to be labeled as higher risk but not actually reoffend. The tool makes the opposite mistake among white people. They are much more likely than black people to be labeled lower risk. We can say that these correlations reflect some existing prejudice. For example, it has been proved that some algorithms trained on extensive sets of tests in the web do reproduce the same human prejudice studied in psychology. The fact that these algorithms are trained on a large number of data, that is big data, makes it even more complex to identify bias and prejudice. Moreover, when these decisions are further used for other training processes, they can magnify the discrimination effect of the algorithm. So far, the approaches that go under the name of algorithmic fairness, that is, the attempt to develop algorithms that are not only accurate but also fair, have only mitigated the problem. Probably one of the most fundamental questions is not how to fix bias with new technical solutions, but whether potentially harmful automated decision systems should be developed. Another problem is connected to the relationship between machine learning systems and their users. Here, risks can derive from the algorithm's capacity to influence human behaviors. According to nudge theory, the way an algorithm can nudge users is soft and benevolent. For example, it can suggest what is considered more interesting for a user, as in the case of recommender systems. However, this gentle push can be dangerous when it becomes a manipulation. Correlations among data can be exploited by someone to influence human behaviors. For example, in the Cambridge Analytica scandal, answers to psychometric tests together with demographic data and online behaviors have been used to predict some traits of personality and hence to possibly define the political orientations of Facebook users. The possible manipulations and loss of autonomy are rarely intentional. Rather, they are indirect consequences of the way some systems are designed. For example, to optimize the number of clicks or of correct answers. Dealing with these issues, different approaches can be adopted. A possible approach is regulation with the goal of promoting fairness, equity, accountability, and transparency in the development and use of automated decision systems. Another approach to fight bias is stating beliefs and assumptions explicitly. This approach is deeply connected to the possibility of auditing these systems, such as suggested by some explainable AI techniques. Also, data quality can play a very important role because, as we have seen, these systems heavily rely on data. In conclusion, these problems are socio-technical. They cannot be solved with technology alone, but require a change of perspective at both a design and regulation level.